Hello, scholars, and welcome to our lesson. This is 3.3 on slope. Our objective today is I can find a slope given a graph, a table, or 2 points. I can find slope given a graph, a table, or 2 points. So in 6th and 7th grade, especially 6th grade, you talked a lot about unit rates. You talked a lot about rates in general, and that's all leading up to this moment when we talk about slope and the slope of a line. So let's dive into like what that means, how to find it, and eventually how it's going to help us graph any line. So this lesson is just incredibly important because the rest of this chapter really just builds off of this idea. And knowing what slope is just foundational. Just foundational. So let's really get a good understanding of it here. So the steepness of a line, we call that slope. Quick question. Circle the line with the biggest slope. What do you think it is? I think it's this one, the most vertical of the lines. Okay, and some notes about slope. The letter we use for slope is the lowercase m. Why? Because it comes from the French word monter, which means to climb or to rise. Fun fact, right? When given the graph of a line, we need to know a simple definition of slope. We're thinking graph here. When we think graph, we're going to think that m equals rise over run. And for me, the big definition of slope here, and rise over run, if that helps you, fine. I'm always thinking a change in a y divided by a change in my x. A change in my y value divided by a change in my x. I wrote a little triangle here. This is actually the Greek letter delta. And delta is how we describe change. How we describe change in mathematics. So I wrote delta y divided by delta x. So slope is a ratio of a line's vertical change divided by or compared to its horizontal change. So we're comparing its vertical change to its horizontal change. So the question now is, how do we find slope if we're given a graph of a line? Well, number one, we're going to mark some points on that line. Okay, I love to use the y-intercept if I have one that's nice and beautiful as one of my points. And then I always just go and try to find the closest one I can find to that one. That's helpful because I won't need to reduce a fraction if I find the ones closest to. But notice the point I chose. I chose points that perfectly hit both the vertical and the horizontal grid lines. I know that this is exactly 0, 1. I know that this is exactly 2, 0, okay? If I picked this right here, I'm not sure what that vertical, that y value is, okay? I want to pick something that I'm certain of what the value is, because that's going to make finding the slope much, much easier. Okay, so we start from the left. So I'm going to start from my leftmost point, and this is what I'm going to do. I'm going to find the rise, or in some cases the fall, how much it's going down, of my line. So how much is my rise? It is, and let's make this note. Up is a positive slope. And if I have to go down and over to the right, I know that that's going to be negative, a negative slope. Okay, so let's find the rise, and that's going to be on top of my fraction, right? So I go up 1. Now I'm on the same plane as my second dot. So I need to go up 1, and you can kind of make a triangle for yourself if you want to. We're going up 1, and then find the run. Let's always run to the right unless we can't go to the right, okay? And we'll eventually see some examples of that, but we always go to the right if we can. If you're having to go up and to the left, then you're actually encountering a negative slope. So it's really nice for us to think about always going to the right, at least at first, as we learn slope. So we're going up 1 and over 1, 2. Over 1, 2. That is my run. We have a slope of 1/2. But let's look at this line a little bit, okay? I mean, this is what we just found. We picked these 2 points here, right? And we found up 1 over 2. It's basically counting the sides of these little triangles. But here's the deal. As you saw, I could have picked this point and this point. And if I would have done that, I would have gone up 2 and over 4. Or I could have picked this point and this point, and I would have gone up 3 and over 6. Or I could have picked this point and this point and would have gone up 4 over 8. Why are they all different numbers? Well, I know you are all brilliant, so you probably already see it. Well, 2/4 equals 1/2. And 3/6 equals 1/2. And 4/8, well, that equals 1/2. No matter what 2 points I pick on this line, this is the same line, I am always going to get the same slope. And that is why we always want to make sure to reduce our slope, okay? And that is always why I pick the 2 closest dots I can find, so I don't need to reduce. But no matter what 2 dots you pick along this line, you are always going to find the same slope, because the slope does not change because it is a line. Turning the page. Well, why don't you try? I mean, at least when you're ready. When you're ready, pause and you try it on your own and then come back and see what I did. Maybe you want to do one with me, though. That's fine. So I told you already I love the y-intercept as 1. And then I'm going to go down. That doesn't quite hit perfectly. Nope, not perfect. Oh, that's definitely perfect. Okay. So I'm basically making a little triangle here, and I'm going to count the sides of this triangle. Now, I need to go down in order to get over, okay? So I know this is going to be a negative slope. Down 1, 2, 3. So this is negative 3 over 1, 2, 3, 4. Now, could you put your negative up here? Sure. I like to put it out front. Could you put it down here? Sure. Same number. But I think it's nice to put out front. Okay, let's continue. That perfectly hits the grid line. That perfectly hits the grid line. Up 1, 2, 3, and 4 over 1. Up 4 over 1. Well, 4 divided by 1 is just plain old 4. This is a slope of 4. Okay. Oh, it doesn't perfectly hit my y-intercept. I'm going to have to find another dot that hits the grid line perfectly. That one looks like it's going to work. Ooh, so does this one. I'm up 1, 2 over 1, 2, 3. Okay, let's see where we are. Ooh, perfect on my y-intercept again. Oh, look at that. Those are really close together. Down 1 over 1. Down 1 over 1. Well, 1 divided by 1 is 1. So this must be a slope of negative 1. Okay, here we go. Ooh, we're going down again. Down 1, 2 over 1. Well, 2 divided by 1 is 2. This is going to be a slope of negative 2. Next. Oh, this is not going to perfectly hit here, so I'm going to use this point and this point. It looks like we're going up 1 and over 1, 2, 3. Okay. So, let's continue. I hope that you're getting the hang of that. Don't worry, I'll let you practice a lot. There are 4 types of slope. As we travel from left to right, if the line is going up, if the values of x are increasing, if the values of x and values of y are increasing, if the line is going up as we go from left to right, this type of slope is positive, and we're always going to get a positive number as our slope. So it's nice to kind of step back and say, is this a positive slope or a negative slope? Because it's pretty easy to see if you read it from left to right. Okay, if as we look at it from left to right, the slope or the graph is going down, we know that this is a negative slope. And this graph is just not steep at all, right? Let's explore. I'm going to make 2 dots. Let's do this one and this one. Okay, let's think rise over run. How much do I go up? 0. I go up 0 over 1. What is 0 over 1? 0 over 0 divided by 1. Oh, that's 0. Well, 0 divided by anything is 0. Let's call this a 0 slope. And you know what? I think any horizontal line is going to have a slope of 0. Okay, well, let's check out a vertical line. This is just ridiculously steep. Can we even call it a slope? It's so steep. I don't know. Let's try. If I was going to try to do rise over run on this, it would be up 1 over 0. We're already there. Okay, let's try this. 1 divided by 0. It broke my calculator. You broke my calculator. Dang it! Okay, my calculator can't do this. I wonder if anybody can divide by 0. Yeah, I don't think that's a thing. So I want to call this, we can't do error. We're going to call this an undefined slope because I can't calculate it. It's undefined. I can't divide by 0. There's no way to represent a change in its vertical nature divided by its horizontal nature. Okay. These are important to remember, please. Moving on. Okay. Finally, I think I'll save this for the next video. Bye.